Animation rigging in Unity lets you control procedural animations. Instead of creating every animation by hand, you can make characters and objects react dynamically. In this video, let's go through the most important constraint and when you should use them. First, you need to know, to make it all work, you need to attach the RigBuilder to the root object with Animator Component on it, and assign the rig layers to its list. All of these rig layers should be child of this RigBuilder in hierarchy. Number 1. Chain IK and 2-bone IK. These are used when you want a character's body parts to follow a target. 2-bone IK is mainly used for limbs like arms and legs. For example, when you want a character to grab an object, the original animation might not always hit the correct position because every environment can be different. With IK, you can dynamically move the hand to the target position. 2-bone IK uses these bones, the root bone, the middle bone, and the tip bone. It also uses a target transform, which is the position the bone is trying to reach, and a hinge transform, which controls direction the middle bone bends toward, like where the elbow or knee should point. Chain IK is similar, but instead of controlling only 2 joints, it works with a chain of bones. This makes it useful for things like tails, tentacles, ropes, or any object made from multiple connected points. Chain IK needs a root bone and a tip bone, and all of those bones in between them will react to reach the target. Multi-aim constraint. Multi-aim is used when you want a bone to rotate and look towards something. Common examples are a character looking at another character, aiming a weapon at a target, or making the character's head follow the direction they're moving. For multi-aim to work, you need to set the source objects and the target which is supposed to look at these sources. You can also play with the aim axis and up axis for different situations. Multi-parent constraint. Multi-parent constraint is used when you want an object to follow different objects without changing the actual hierarchy. A common example is a character pulling out a sword. While the sword is stored, it follows the sheath. When the character grabs it, the influence switches and the sword follows the hand instead. For multi-parent to work, you also need to set the source objects and the target, which is supposed to be their child. In our example, the target would be the sword, and the sheath and hand bone will be the source objects. Multi-referential constraint. This one is very interesting. It allows you to switch which object acts as the main parent for the other. For example, in an FPS game, when the gun is ready to shoot, you can make the hand follow the gun. This means the recoil from the gun can directly affect the hand without needing a separate animation. It helps you create more realistic shooting animations. Then, when reloading, you can switch the control back so the hand drives the gun movement. The way you set up this constraint is that you just put the objects in the reference list and switch the driving object whenever you need. The twist chain constraint. Twist chain is used to distribute rotation across multiple bones. You can use it for animating long and flexible objects like trees, poles, or any object that is not as loose as a rope but is still flexible. This is how it's set up. First, your chain should look like this. Every node is a child of its previous one. Then, in the twist chain component, you set the root and the tip of this chain, and the root and tip targets. Then, when you rotate the targets, you see this bendy-like deformation on your object. The curve in the setting changes the shape of this deformation, which the best way to understand it is to experiment with it. Multi-position, rotation, and blend. These are some of the most underrated constraints. They allow the objects to copy position and rotation from different sources and blend between them. Example use cases are when you want the car wheels or plane wings rotate based on a single controller. Or a more interesting use case is when you want to add some procedural noise to some character animation, like hands and fingers to make it more realistic. Multi-position and rotation are self-explanatory. And the blend constraint is basically both of them, except it works only on 2 source objects. Their setup are very similar. The source objects are the objects which their transforms are used as the main value, and the constrained object is the one which is supposed to be controlled by the source. And that's it for Unity Animation Rigging Package. Hopefully this gives you a clear idea of what each constraint does and when to use it. If this video helped you, consider subscribing because I'll be making more Unity tutorials like this. Thank you for watching, and I'll see you in the next video.